Let's walk through an example that involves the motion of a particle. This can be a pretty hard problem, but we're going to go through it step by step to make sure you totally understand it. We're told that a particle moves along a straight line according to the law of motion. S of t is equal to t cubed minus 9t squared plus 15t plus 10, where t is time and it is greater than 0, and it is measured in seconds, and our position function s is measured in meters. We're going to begin by finding the velocity at time t. Let's go ahead and let's write down what the position function is. We're given that right above. S is t cubed minus 9t squared plus 15t plus 10. The velocity is the derivative of the position function, so we're just going to take the derivative with respect to t, and this gives us 3t squared minus 18t plus 15. And that's what the velocity is equal to. Let's look at the next part. We are asked to find when is the particle at rest. Whenever the particle is at rest, the velocity of the particle is going to be equal to 0. So we have to find t when the velocity is equal to 0. We're going to take our velocity function that we just found, 3t squared minus 18t plus 15, and we're going to set that equal to 0. Let's pull out a 3 and see what we have. We have t squared minus 6t plus 5 is equal to 0. We can factor that. This gives us 3 times t minus 1 times t minus 5, and that's equal to 0. This means we're going to set t minus 1 equal to 0, and we're going to get t is equal to 1 second. And then we're going to set t minus 5 equal to 0, and we're going to get t is equal to 5 seconds. So our particle is at rest at 1 second and at 5 seconds. Let's now look at part C. We want to find when is the particle moving in the positive or negative direction. A particle is moving in the positive direction when its velocity is greater than 0, and then it's moving in the negative direction when its velocity is less than 0. So what we're going to have to do is find when the velocity is positive and when the velocity is negative. I'm going to start by writing down our velocity function in the factored form. We just found this. It's 3t minus 1 times t minus 5. And we know that our velocity is equal to 0 when t is equal to 1 and when t is equal to 5. So what we're going to do is we're going to look to the left and the right of 1 and 5 to see what the velocity is equal to. Let's go ahead and let's draw a number line. This is our time, and we're going to put in that time starts at 0, and then we have 1, and then up here we have 5. It's okay if it's not drawn to scale. I'm going to put on here that at 1, our velocity is 0, and at 5, our velocity is also 0. We have to look in this region, and this region, and see if our velocity is positive or negative. I'm going to create a table over here. I'm going to put down t, and then I'm going to put down t minus 1, t minus 5, and then our velocity function. So what I'm going to do is I'm going to pick a point in each interval and then see if t minus 1 and t minus 5 are positive or negative, and then we can tell what is going on with the velocity. Between 0 and 1, I'm going to pick the point 1/2. So 1/2 minus 1 is negative, and then 1/2 minus 5 is negative. So when we multiply two negatives, we're going to get a positive, because our velocity is t minus 1 times t minus 5 times 3. Now I'm going to pick a point between 1 and 5. I'll just choose 2. 2 minus 1 is positive. 2 minus 5 is negative. So our velocity is negative. And then lastly, I'm going to pick a point that is greater than 5. So let's just say 6. 6 minus 1 is positive. 6 minus 5 is positive. So our velocity is positive. So I'm going to add in our table here that our velocity is greater than 0. In the middle region, it's less than 0. And then in our region on the right, it is greater than 0. We can conclude then that our particle is going to be moving in the positive direction when our velocity is greater than 0, and that happens in our first region when t is between 0 and 1, and then in our region on the right when t is greater than 5, and then our particle is going to be moving in the negative direction in our middle region, and that is when t is between 1 and 5. It's moving in the positive direction for these values of t and the negative direction for those values of t. In part D, we are going to draw a diagram to illustrate the motion of the particle. Since it's talking about the motion of the particle, I am going to go ahead and write down our position function. S is t cubed minus 9t squared plus 15t plus 10. To illustrate the motion of the particle, we want to find our position function s when t is equal to 0 and v is equal to 0. That will be our mean position points, and then we'll fill in between. Let's first look when t is equal to 0. All we have to do is look at our equation for s and substitute in that t is equal to 0, and we get that s is equal to 10. Let's now look when our velocity is equal to 0. We actually already found this. This is going to happen when t is equal to 1 and when t is equal to 5. When t is equal to 1, our position function is 1 minus 9 plus 15 plus 10, just plugging in for t. And this gives us 17, and we need to put units on this. Our position is in terms of meters, so I'm going to write down 17 meters. When t is 5, s is going to be 5 cubed minus 9 times 5 squared plus 15 times 5 plus 10. And when you add all of that up, you end up with a value of minus 15 meters. Now we're going to go ahead and start our diagram. The time values that we're interested in are t is 0, t is 1, and t is 5. And then the position values are 10. And I just realized I did not put meters there, so I'm going to put in meters. And then we have 17 and minus 15. Since this diagram illustrates the motion of our particle, we're going to have a number line here, and this is going to be in terms of our position s. The position numbers I highlighted in orange, so we need to put in minus 15. We need to put in 10. This is not really going to be to scale. And then 17. When t is 0, our position is 10 meters, so I'm going to put a dot here, and I'm going to mark this t as 0. When t is 1, we are at 17 meters, so I'm going to put a dot here and put in t as 1. And then when t is 5, our position is minus 15. Now we can go ahead and draw the motion of our particle. It's going to go along this way, and then it's going to curve along the other way until we get to 5, and then it's going to change directions again. So we'll put some arrows on here, and you can see the motion of our particle. In part E, we are going to find the total distance traveled during the first 8 seconds. We are going to use the graph that we just drew for part D to help us answer this. We are going to have to divide our distance into 3 parts. This first part, where our velocity is positive, and then this second part, where our velocity is negative, and then the third part, where our velocity is positive again. So we're going to write down that our distance is equal to the absolute value of s at 1 minus s at 0. And then we're going to have the distance for the portion that I outlined up here in purple. That is going to be s at 5 minus s at 1. And then our second blue piece, which is going to be s at 8 minus s at 5. Let's go ahead and see what this is. Let me pull this back down so we can see these numbers. S at 1, we calculated up top, and it was 17. So this is 17. S of 0 was 10. And then S at 5 was minus 15. And we're going to subtract off S at 1, which was 17. And then we're going to get to the part that we don't know yet, and that is S of 8. Let me go ahead and highlight this. That one we actually haven't calculated yet, so let's go ahead and let's do that. S at 8 is going to be 8 cubed minus 9 times 8 squared plus 15 times 8 plus 10. And that ends up being equal to 66. So now we can go back up and plug in that S of 8 is 66. And then we subtract off S at 5, which was a minus 15. So you have to watch your negatives here. Let's come down here and see what we have. This is going to be 7 plus the absolute value of minus 32, which is just 32. And then we have 66 plus 15, which is 81. And this adds up to be 120, and we need to put units. It is in terms of meters. So the total distance traveled in the first 8 seconds is 120 meters. Now let's look at part F. We want to find the acceleration at time t. The acceleration is the derivative of the velocity. So let's start by writing down our velocity function. V is equal to 3t squared minus 18t plus 15. Our acceleration A is v prime, and that is 6t minus 18. So there's our acceleration. Now we have one last part, and it is challenging, but I'll show you exactly what to do. We need to find when the particle is speeding up or slowing down. Our particle is going to be speeding up when our acceleration and velocity have the same sign. So let's write down A and V have the same sign. And then it is going to be slowing down when A and V have opposite signs. To solve this problem, we need to focus in on when the velocity is 0 and when the acceleration is 0, and then look at the intervals on either side of those points. We already looked when the velocity was equal to 0. That happened when t is equal to 1 and t is equal to 5. Now we can find when our acceleration is equal to 0. We just take our acceleration function 6t minus 18, set it equal to 0, And this gives us that t is equal to 3. So we are going to draw a number line, and we're going to put the points 0, 1, 3, and 5 on it. We're going to start at 0, and then we have 1. It doesn't matter the scale. We have 3, and then we have 5. In one of our previous problems, we saw that our velocity was greater than 0 in this region, and it was less than 0 between 1 and 5. And then when t is greater than 5, our velocity was greater than 0. Now we're going to do the same thing for the acceleration. Our acceleration is going to change signs when t is equal to 3. If we look at 6t minus 18 and pick a value less than 3, let's just say 1, we're going to see that our acceleration is negative. So I'm going to write down that a is less than 0 here and less than 0 here. And then if we pick a point that is greater than 3, say 4, you can see that our acceleration is positive. So we'll write down a is greater than 0 and a is greater than 0. Now let's look and see when it's speeding up. The particle is going to be speeding up when the acceleration and velocity have the same sign. That happens in this region and in this region. So we know the particle is going to be speeding up when t is between 1 and 3. And then when t is greater than 5. And it's going to be slowing down in this region and in this region. So that is when t is greater than or equal to 0 but less than 1. And then when t is between 3 and 5. So this is when our particle is speeding up, and this is when our particle is slowing down.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.